So in this lecture, we're going to access the credentials because of insecure data storage vulnerabilities. So after getting the encrypted data, we'll decode them and then hijack the username and password. Sound like a plan? Let's start. As always, we'll make sure that the Android emulator and application server are running. And here we're looking at the do login activity last. And something must have caught your attention here. I'm going to wager. So when a user logs in, the credentials are saved using the save creds method. So this method creates a new file called My Shared Preferences if it doesn't already exist. The method then, base64 encodes the username and encrypts the password with AES encryption before storing them in the shared preferences file. And then this file is overwritten each time a user successfully logs in with their own credentials. So let's have a look at the login activity class. As you can see, there's a method called fillData, and it enables users to autofill credentials in order to save them from having to enter in their username and password every time they wish to log in. The fillData method is opening the My Shared Preferences file. The username and password are decoded and decrypted respectively before being used to fill in the login input fields. Now, as you remember, the password is encrypted with AES encryption using crypto class. So let's also have a look at this class. And the password has been encrypted with a method called AES encrypted string. Now, we saw that the developer was using AES encryption with the cipher blockchaining mode, but used a static initialization vector and hard-coded the encryption key. So we can decode a password using this static initialization vector and hard-coded encryption key. So first, let's get the credentials from the InsecureBank app. We can use ADB to identify where the My Shared Preferences file is stored in the InsecureBankv2 app's private directory. So open up the terminal, and first we'll check the devices. All right, so when you can verify that you're connected, run the ADB shell command. Now, don't forget that the My Shared Preferences file will not be created until you've logged in successfully at least once. All right, so we'll make sure that we've successfully logged into the app. And we'll log in with the default credentials. Okay, so now we can go to the directory where the shared preferences file is. So it should be under the folder called data/data/com.android.insecurebankv2/sharedprefs. And list the files. All right, so here it is. So let's copy the location. And we'll use the exit command to get out of the shell. Now, to get this file, run adb pull location of the file. And don't forget adding the file name and the location. All right, so that pulls the file. And let's open the file with Nano. So as you can see, the password is in encrypted form, but it should not be forgotten that base64 is not secure, because base64 is not encryption. It's encoding. It's a way of representing binary data using only text characters, so we can retrieve the username quite easily using an online tool such as CyberChef. In fact, we can decode the username and password. So just open the web browser, search for CyberChef, and click on the first website. Select to base64 as the option from the left pane. So we can start with a username. We'll copy this, paste it into the input field, and there you see it. There's the username, quite easily gotten. So why don't we just continue with the password? And what do you think? All from the source code, we have the information needed, such as encryption key, initialization vector, and ciphertext, so that we can decrypt the password. So we'll just copy this part, paste it into the input field. Now, before decoding the AES encryption, we'll need to decode the base 64 password and encode it to hex. So I'll just add the to hex option into the recipe field. And this is the hex format of the password. So we'll copy it, and now we can start the AES decryption. Open the encryption encoding section from the left pane. Select AES decrypt. Now we can disable these options because we'll just use the AES encryption now. So paste the hex format of the password here. Open the source code and copy the key and paste it into the tool. Now copy the initialization vectors. So this is in an array format in the Java programming language, so that means we'll need to transform it into the hex format again. We'll just remove the commas and add one more 0 for each one. The value of all the initialization vectors is 0, making it predictable and easy to decode the password. Mode is OK, as you remember from the source code. It was CBC, which, by the way, stands for cipher blockchaining. Oh, and don't forget to set this mode to UTF-8. All right, great. We've also got the password. So here's the result of insecure storage of data.